Good evening, everyone. So today I'm here to explain how we can implement a fully functional matrix in Python. Okay, so in the left side you will see I've showed you the handwritten note of the matrix, and in the right side you will see the implementation, the exact implementation or the code of implementing matrix in a Python. Okay, so first of all, why I have provided this handwritten notes, it is very important because without this handwritten note it is very difficult for understanding the implementation of matrix in Python. And I have implemented matrix in Python without the strongest library, NumPy. Okay, without NumPy I have tried to implement matrix in Python. So first of all, to implement matrix there are some rules. There are two thumb rules we need to keep in mind. Okay, so first one is, you will see here and it is also written here. Okay, so if you see, I have zoomed this image, you will see the number of columns, the first validity condition. Okay, the first thumb rule is number of columns of A, matrix A, is equals to the number of rows of matrix B. Okay, it should be equal to number of rows of matrix B, because if the number of columns of matrix A, first matrix, is not equals to number of columns of, sorry, number of rows of second matrix, then multiplication cannot be possible. Okay, because the row of the first matrix will be multiplied with the column of the second matrix. Okay, now, and the second rule is resultant matrix size. Now, if we multiply both the matrix, then what will be our resultant matrix size? Resultant matrix size will be rows of first matrix or matrix A into row columns of matrix B. Okay, so if you consider this matrix, two matrix, okay, so you will see the resultant matrix will be rows of matrix A. So here two rows in the first matrix, matrix A, so two rows will be there, and columns of matrix, second matrix. So column is two, the two rows and two columns in the resultant matrix. Now I have shown you different approach of implementing matrix in different programming language. Not implementation, but I have provided you how to store the values inside the matrix in different language. Suppose in Python, if you see in Python, if you focus on this in Python, you will see we can perform matrix without numpy by using nested list. Okay, in Python. Okay, first of all, this is the outer list, and inside that there are two in list objects. Okay, two list objects. Okay, and these two list objects are stored in a different memory location, and this outer list is stored the reference of those two list objects. Okay, so basically, these two inner list is stored in different memory location. Likewise, in case of matrix B also. But in case of C language, the implementation is same, but the value stored inside the memory is different. But in case of C language, you will see the values of the particular matrix or particular matrix is considered as a single block of memory. Okay, so all the values inside the matrix is considered as a single block of memory. Okay, but the implementation is same only. We can implement in the implementation is same, like the implementation for C language and for Python is both the same, but the storage is different, like storing the values inside the memory is different. Okay, so now if you consider this example, suppose I have written, so what is that in the first matrix, suppose 0 0, here it is present 1, 1 will be multiplied with the second matrix 0 0. Okay, 5, 1 into 5. Okay, second is we will come with 2 0 1, 0 1, 2 will be multiplied with column wise 7. Okay, 1 0. Okay, see, 2 into 7. And next in the third part, here only, again 1 6, 1 will be multiplied with 6 and 2 will be multiplied by 8. In this way this also works. 3 will be multiplied by 5, 4 will be multiplied by 7, and again 3 will be multiplied by 6, and 4 will be multiplied by 8. Okay. Now we will see the, and this part I will explain later as we go through the code. Okay. So now let's come to the code part. Sorry. Let's come to the code part. You will see matrix, the thumb rules are written, two thumb rules are written. Okay. So now we are taking the size of the matrix. Okay. For R1 means the first matrix rows, number of rows of first matrix we need to provide, and the number of columns of first matrix we need to provide, R1 and C1. And same for second matrix, number of rows and number of columns for second matrix. Now the first thumb rule check. Okay. Multiplication if possible or not. If C1, see the thumb rule, the columns of A must be equal to the rows of B. See, C1 not equals to R2. If C1 not equal, if columns of A not equals to rows of B, then multiplication not possible. Okay, this is the first rule. Else we will take the input in the matrix. Okay, we will form matrix in this kind of matrix, and we will take the input 1 2 3 4 like this. Okay, so if you see here, what I have done, I have printed statement enter elements of matrix A, then I have declared a list. Okay, list name is A, that means the outer list I have declared, that is A. Then again I am running a for loop, the range of R1 is 2 here, we know R1 is 2. Okay, see, R1 is 2. So the first row is created inside the A list, there is another list is created. Okay, that is the first inner list. Okay, then we will put the value. Okay, we will put the value int input integer, we are taking the user input as integer. A of 0, I is 0 and j is also 0. A of 0 0 equals to that. Okay, 0 equals to whatever number the user will provide. Suppose 1 is provided. Now what it will do, row dot append, we are appending the value inside the row. Then 1 is provided, 1 will be appended in the inner list, then in the, and then what will happen, again it will come back to j. Okay, j will be incremented, suppose 1. Okay, so 1, again input taken, 0 1, I is 0 and j is 1. So this part 0 and 1, this part 2 is provided, so 2 is taken. Row dot append val 2 is taken, 0 and 1, 1 and 2. Okay, now j is 2, condition will be false. Okay, now it will go to the append part. Now A, like the row will be appended to A. Okay, means this whole row that will be appended to inside the list A. Okay, like this entire list will append to the list A. Okay, it is stored, the inner list is stored in list A. Okay, then again it will increment the I, again the same process will done, and again in this way the second inner list will be created and it will be append to the A. So first matrix is formed. In the same way I have created the second matrix also. Sorry, in the same way I have created the second matrix also. Okay, like I will provide the code in the description box. Okay, provide the file in the description box, just look after this. Okay, in the same way I have created the second matrix also. Now what I will do, initialize result matrix. Okay, now why I will initialize the result matrix, because if I with 0, okay, if I didn't initialize the result matrix every places with 0, then I cannot like insert the multiplication value in that matrix. Okay, the resultant matrix only we will insert the multiplication value. Suppose this 1 into 5 plus 2 into 7. Okay, it provides 7 into 14 and 1 into 5 means 19. 19 will be placed in 0 0. Okay, the resultant matrix 0 0 19 will be placed. But how I will placed? From the resultant matrix. Resultant matrix is already initialized below with 0, and I will replace it the 0 by 19 in the 0 0 position. Okay, in this way. So that's why we have to initialize the matrix. Okay, resultant matrix, all the positions with 0. So result, again list I have created, again for I R1. Now the resultant matrix will be created like these, rows of first matrix and columns of second matrix. So we will run a for loop till row 1, like rows of first matrix, then again I will create a row, two rows will be created, okay, because rows of first matrix is 2, okay, and then for j in range to c2 means columns of second matrix, two columns is there in the second matrix, that why two columns will be created, and then what we will do, we will append 0 in the row means 0 0, okay, 0 0, and result equals to result dot append row, and we will store this to list inside the resultant matrix, okay, resultant matrix, it's done. Now this is the resultant matrix. You will see like a matrix is created with every position is created with 0, okay, just I have initialized the resultant matrix, okay. So first of all I will just by executing this code, how this like how this part is created, how this nested like matrix is created, like in the form of list, I will just show you, and how will it take elements for every position to uh, initialize it, initialize the numbers into the nested list, okay. Just I will run it and you will see how it is works, okay. So matrix multiplication, if I, it is telling enter rows of matrix A, okay, so I will tell row 2, okay, columns of matrix A, that is also 2, then columns of rows of matrix B 2, columns of matrix B 2, okay. Now it will, it is telling for A00, it is telling to provide this, the provide the number for this position, okay. So I will tell give 1, then 2, then 10 means this part, then 3, then 4, picture is already there in front of you, just match if I am giving same input or not, for your understanding, okay. For then 5 I will give, then 6 I will give, then 7 I will give, then 8 I will not provide the, I will not press enter. If I press enter, then it will provide the resultant matrix, okay. So I will explain you how the matrix for the matrix multiplication logic, how it is working, okay. Then I will press the enter, you will see the matrix will be there, okay. So we have initialized, okay, we have initialized, okay, with 0 the resultant matrix. Now how for the matrix multiplication, let me increase the size, matrix multiplication logic, that is, you will see for I in range r1, okay, r1, what is our r1, that is 2, okay. So I will run till 2, okay. Now f of I 1, I is printing, I now I is 0, okay. For j in range c2, now c2, c means columns of second matrix, that is 2, so j is also now 0, okay. So j I am printing, you will see that will be printed there in the terminal, I will see you like I will show you after execution. Now pressing the enter for k in range, now we are using k because we need k to multiply multiply to do multiplication between two matrix, okay. So k in range c1, okay. So now print k, okay, k is also 0 here. Now you will see like carefully see how k is working, I and j it's still there, but how k is working you will see, okay. Now resultant matrix, resultant matrix I 1j, 1j means 0 0, I 0 0, that is the resultant matrix. Resultant matrix is 0, this position 0 0 0 0 position, this first position 0 0, first position, so equals to, that is result ij means 0 0 position, which value is there, 0 is there, 0 is plus, we are doing the plus a of ik, ik means I is there 0, k is there 0, ik, so a of ik means it will, a of ik means 0 0 1, 1 is there, 1 is there, there 1, okay, into star means it will act as a multiplication operator, okay. So b of kj, k is there 0 and j is also 0, then it will 5. So 1 into 5. Okay, 0 plus 1 into 5. Okay, then 5 will be stored in the resultant matrix in the 0 here. 5 will be stored. Okay, then again it will increment the k is now 1. K is now 1. See, k is now 1 in the second iteration. K is 1. Okay, now print k, done. Okay, resultant matrix of ij, same place pointing. Now result of ij 5 is there. Okay, now a of ik, now a of ik is 0 1, 0 1, 0 1 is 2, 2 is there. That means this is a 2. Okay, and here we will provide kj. Kj means 1 0, 1 0 means 1 0. This is 7. So 2 into 7, 2 into 7, 2 into 7 means 14. 14 will be added with 5. 14 plus 5 is 19. Okay, it's done. First position is down. Again it will increment k, but now condition will be false. It will increment j. Now j equals to 1. J equals to 1. Now j equals to 1. Then k equals to 0. K equals to 0. Then ij. Now ij means 0 1. Now j equals to 1. Ij means 0 1. 0 1 is pointing this position. Means, sorry, this position, this zeroth position, this zeroth position. Now ij is 0 plus ik means 0, I0. Now 0 0 1, again 1 is there. See this part, again 1 is there. Okay, just reduce it. Again 1 is there. Okay, now 1 into kj means now k is 0, I is 1. Okay, k is 0, I is 1. Okay, now k is 0 0, I is 1. Now k is 0, j is 1. Okay, k is 0, j is 1. Okay, that means 6. So 2 into, sorry, 1 into 6, 0 0 here, and suppose I and k. Okay, I and k 0 and kj means 0 1. Okay, means 6. 2 into 6, sorry, 1 into 6. Okay, 1 into 6 is there, plus now again it will increment the k is now 1. See, k is now 1. Okay, k is now 1. Then ij is pointing to the same part. Now it is going to be 6. Okay, same part. Okay, now it will add, means ik now k is 1, I is 0, 1, sorry, now k is 1, I is 0. Okay, now it will point to the this part, this part. Okay, 1 1. Okay, k is, sorry, k is 1 and j is also 1. Okay, sorry, k is 1, sorry, uh, k is 1, sorry, k is 1 and I is 0, then 1 0. Now I is 0 and k is 1, that means this 2 will be pointing. Okay, now and then kj. Kj means k is also 1, j is also 1. For b, k is also 1 and j is also 1, means 8. 2 into 8, 2 into 8, 8 to the 16, 16 plus 6, 22. 22 will be in that way also. Then again it will go back to the k will be false. Again it will, I think this will also false. Again I will be incremented in this way. This is also change, this will also change. Okay, so I will execute the program and press the enter, and you will see the resultant will be, the resultant matrix will be there. See, I have printed the ij, how the I, j and k is updating, and the resultant matrix is 19, 22, 43, 50. So that's all about matrix multiplication in Python without the powerful library NumPy. So in my next video, okay, I will implement matrix multiplication using NumPy. So wait for that video. It will be very soon. So till then, bye bye.